Welcome to Quant Platform Statistician for Finance 372. The statistician's job is to take the raw results of a backtest and tabulate them into statistics and plots that we'd like to look at. So let's have a look at the code. In this notebook, we're going to define a backtest statistician that's designed to look at historical results from a backtest. This component is going to require little to no change across your different backtests. And so again, I'm going to go through the code directly rather than building it up from scratch. Because we're doing all these different statistics here, we need to import a few extra libraries into this statistician. The only one we haven't seen before is this OS library, which is what we're going to use to create new folders in which to store our results. Okay, in this backtest statistician class, we're going to need to refer to where a CSV file is called Market Risk-Free Daily, or MKTRF Daily. This is the file we're going to use when we need to compute betas for our strategy. Okay, having a look at this file, I included it in this folder here. You can see that it's a very simple file. It has, for each date, the cumulative index for the market and a cumulative index for the risk-free rate. You can see if you go down to the end here, these are big values because this is cumulative compounded index levels. Okay, the reason to do this way is if I want to know the return in September of 92, I can compare the index value at the end of September to the index value at the end of August, and I can do a division here to figure out the return in September of 92. And I can do the same with the risk-free rate, and I can do the same if I'm using daily returns by just comparing day-to-day index values, or annual returns by comparing longer-term index values, etc., etc. Okay, so you can have this file in whatever folder you want. We just have to refer to the path to get to that file right here. Okay, next we have the constructor for this class. We're going to pass in a reference to our portfolio database because this is where we're going to get out the count history data frame. And we're also going to pass in a reference to a strategy info dictionary. So this dictionary is going to contain everything up here. So it's going to contain a brief descriptor, which is a description of the strategy that we're going to use in the folder name, a plot descriptor, which is going to be what goes on the plots that we create, and then some extra fields that explain what the strategy is, what the universe is, what the signal is, what the trading rule is, what the holding period is. And then we're going to have this periods per year field, which tells us how many periods per year. This is what we're going to use for annualization. And then a time lag descriptor. The idea with strategy info is that when we set up the backtest in our backtest file, which we'll get to in the next video, we're going to make ourselves write out exactly what's in this backtest. And then when we do the output here as part of the statistician, we can record in the folder that is the output exactly what the parameters were that led to this backtest. So this way, when you go back later and you have a bunch of different folders for some different backtests, you can remember, okay, how did I get what's in this folder versus what's in that other folder? Okay, once we create a backtest statistician, the main function we're going to call is output stats, and we're going to tell it a folder where we want the output to go. So in my example here, this output folder is just going to be capital O output. Okay, and then our first step is to create within the output folder, we're going to have lots of different subfolders that represent each of the different backtests. So the idea is each time you do a backtest with the same code, you create a new subfolder of your output folder that represents the results of that backtest. Okay, so to create this subfolder, we're going to use this make backtest path function. So how does that function work? It's down here. It starts with the output folder, which is in this case output. Within the output folder, it's going to create a folder whose name is starting with the brief descriptor. So in this case, for our book to market decile strategy, our brief descriptor is going to be BM Des EW, EW standing for equal weighted. And then we're going to add on to that these numbers which represent the date and time at which the backtest was completed. Year, month, day, hour, minute. So hour in 24-hour notation. So this one was completed 11:19 p.m. on March 25th. So the way this function works is it tries to create the folder with this path name here. But what can happen is if we have too many backtests going and we end up creating two of them that have the exact same folder name, two of them finish in the same minute, for example, or we're trying to output the same results twice in the same minute, well, then what we'll do is we'll create a new folder that has the same name but with a 1 in parentheses afterwards. So this is what Windows does. For example, when you try to download a file to a folder and it finds one that already has the same name, it adds a parentheses 1 or parentheses 2 or 3 or 4 after that. Okay, so this code down here just makes sure we find eventually a unique name for this subfolder, and then we create that. So now we have the path we're going to use, and everything else we want to output, we put inside that folder. So it's going to go inside here. And the first thing we output is just an account history CSV that comes straight out of the portfolio database. So we can see what that looks like here. This has the NAV as it evolves over time, cash position, and margin requirements as they evolve over time. We'll do the same things with the trades data frame. That's going to be an even bigger file because we have all of the trades that we made as part of this strategy. The quantity, the open average price, the close average price, the book to market ratio that got us in there in the first place, our security ID, and when we opened the thing. Okay, you can see here this thing has 450,000 trades that we made as part of this historical strategy. All right, so that's the raw CSV files. We have those. That way we can go back and do additional analysis later if we want. But now we want to compute some statistics that are a little more interesting and readable than those big raw data dumps. And we're going to put those statistics into a dictionary called backtest stats. All right, and most of the statistics are going to be based on the series of returns that we got. So I'm going to take that NAV history and compute a return series by doing a percent change, dropping the ones that we don't have. And I'm just going to get rid of the index here too. All right, and then to do the annualization, as I mentioned before, we're going to have the number of periods per year come straight out of our strategy info. First thing we'll compute is an arithmetic mean, which is just the return series mean. We can annualize that by multiplying by n. We can compute a geometric mean using the stats.gmean function. We've already removed the NA values from returns, so we will be okay using this gmean function. And then we can annualize that by taking this to the nth power and then subtracting 1. Okay, so those are our means. In terms of risks, we can compute sigma or standard deviation just as the standard deviation of returns. We can annualize that by using the square root of n. We can also compute a drawdown. Drawdowns, you get that by comparing the NAV at the current date to the maximum that we had up to that point. So this cum max is cumulative maximum. Any given row of this cum max will be the maximum value at that row or earlier. So that's exactly the high water mark that we had in the notes. So you take the NAV divided by the high water mark, that's always going to be less than 1. How much less than 1 it is, that's the drawdown. So we do 1 minus the ratio of the NAV and the high water mark. Okay, once we have a drawdown, then we can do the average drawdown statistic and the maximum drawdown statistic. Okay, to do alphas and betas is when we need to do one of these regressions. And so you're going to need to do to get the market and risk-free rate data frame out of the market data path that I just showed you. Make sure that the date has a date time, because this is a CSV file. It's not going to come in as a date time 64, so we need to convert that over. All right, and then we're going to narrow down this data frame to only the values whose dates are in our account history. So you can see our account history data frame has these dates, whereas Market RF Daily has way more dates. So we're just going to narrow down these dates to only the ones that are in here. Okay, and then from that we can get our market series and our return series by again doing a percent change and dropping the NA values like we did with the NAVs to get the return series for our strategy. Okay, and now we can set up the left-hand side as the return series and the right-hand side as the market series minus the risk-free rate series, and we'll add a constant to that. So this is going to be our alpha and beta regression. Notice here that I'm not subtracting the risk-free rate from the return series. And what I'm doing is I'm assuming the return series that you've passed in here is already an excess return above the risk-free rate. The reason this works is that we have the code set up right now to not pay you interest on your cash balance. Okay, so in reality, our return series and our backtest would give you a little bit higher returns because our cash balance will get interest. But that's just going to give you the risk-free rate every period. And so because we didn't add that, it's the same thing as if we added it and then subtracted it out right here. So our return series is already an excess return because we're not giving you the risk-free rate on your cash. And so we can just leave it like this. If you were doing a strategy where you were not keeping a cash balance equal to your NAV, you can see here that I'm keeping a cash position equal to my NAV. If instead I was doing a long-only strategy or a short-only strategy, or I was bouncing my cash position around over time, then I would want to make sure that I paid the risk-free rate into my actual cash and then came back here to the statistician and subtracted out the risk-free rate to compute my alphas. I have the left-hand side, the right-hand side. Now I can do my regression by using the OLS function in the stats model package, and then I can fit that model to get my results. And to abstract my results, I can get the constant out of that will be my alpha. The standard error for my alpha will be the standard error for my constant. I can annualize both of these by multiplying by n. And then my beta is just the coefficient on the first right-hand side variable that's not the constant. And then I get the standard error that way. Remember, you don't annualize betas because they're already in a return for return basis. Okay, finally I can compute some ratios. I can compute a Sharpe ratio by comparing the arithmetic mean to the standard deviation. I would, again, not subtract the risk-free rate here because we're already getting an excess return in the arithmetic mean. If you were doing a strategy where the cast position was different than the NAV, then you'd want to go back again here and compute a Sharpe ratio subtracting off the risk-free rate. Okay, and then we can annualize our Sharpe ratio by taking the annualized mean and annualized standard deviation. We can also do an information ratio by putting alphas in the numerator instead of arithmetic means. Okay, we have this dictionary now that contains all of our backtest stats. We can turn that dictionary into a data frame pretty easily and then output that data frame to a CSV. So you use the fromDict command to take a dictionary and turn it into a data frame. We can turn that then into a CSV file and put it into the backteststats.csv file. Okay, so the bottom line out of all this is you get in your output folder here, you get backtest stats that have all the stuff we just computed and then all the numbers here. All right, so then we can grab that and put it into Excel and then start putting it into our presentations or our write-ups. Okay, so those are the stats we compute. Next, we need to make a pretty plot of the cumulative net asset value in our backtest. So to do that, I'm going to use this navplot function, which goes right here. Navplot function uses a lot of the code we talked about way back in our plotting data video, where we're going to use this matplotlib. We're going to set our style to default. We're going to set up the figure a little bit, and then we're going to pick the dates to use for our x-axis, and we'll plot those dates, and the y-axis will be the NAV divided by the initial NAV. So the idea here is, no matter what NAV you started with, let's just assume you start with $1 and do the cumulative return from there. All right, and then we just modify that plot a little bit so that the X label is date, the Y scale is log, so we can see a straighter line instead of something growing exponentially. Just locate the tickers a little bit, and then we can put, in terms of the Y label, we can use the plot descriptor here. So this way our Y label will match whatever our strategy is, as long as we set that strategy info and pass that in here. We'll set the axis to be tight so there's no gaps on the right-hand side or the left-hand side. All right, and we'll just label the x-axis with a formatter of just give me the year on the x-axis. And then after all our normal matplotlib tricks, we will save the resulting figure inside the backtest folder under the name navplot.png. All right, and we'll add a couple extra parameters here so that the picture looks nice. You can see what those look like here. They're big high-res pictures, and we can scroll over here and see it's got the labels as the x-axis, as years, and we can see this log scale where we're doubling each time here. And that's it. That's the backtest statistician. This is meant to be the basic statistats that we talk about in class. You can, of course, extend this and modify this to present additional statistics, maybe do some extra plots. If you start having a strategy that is worried about margin requirements, then you can plot margin requirements over time and you sort of count the number of violations you get. You can also compute new regressions. If you want to put a multi-factor model in here, this would be a good place to do it. Hopefully this code is simple enough for you to build upon and extend if you need to, or just use it as is for your projects.